Software Engineering Radio, episode 43, Extreme Programming Part 2.
Hi everybody, this is Alex and Arno again speaking about extreme programming. Actually, this is the second part of the episodes about extreme programming, and this episode is taking a more overall process related and business and context and organization related look at extreme programming. The first episode explained the more technical hands-on side of things, and this time we'll start by looking at the practices of extreme programming, but we're now going to look at those practices that are more related to the overall process, to the context in which extreme programming is. And then we'll look at the context of a project doing XP, how to get the buy-in, how to get it started, what rhythm it has, how deliverables are done, what sort of contracts you can do. So extreme programming in the context. So, shall we dig in?
Yeah, and I guess we should start with the user stories, which are great.
What are user stories? It's not like bedtime stories, is it?
Maybe sometimes. User stories are the heartbeat of an XP project. Actually, they are the requirements, but they are more than this. In XP, you don't do a lot of extensive requirement work. You don't do a lot of use case diagrams and all that stuff. What you do is actually you ask your customer to give you the story or the feature he wants to have. That's why it's called a user story. So it is kind of a use case centric approach. It's feature driven. And the story is actually, it behaves or feels like a story, for your customer. And this story, is written down on an index card, and, it's just a 1 or 2 sentence thing. You don't do all the deep and fancy requirement stuff requirement collecting stuff you can do there. It's more like a promise for communication. That's how it's called in some XP literature.
So story might be a little misleading here. Actually, you just take an index card and write 1 or 2 sentences that explain at the abstraction layer of the customer some feature or something that should be in the system you're building.
Exactly. So something like calculate rates for whatever. It's just a simple sentence, long enough to that the customer is able to remember what he wanted once he has written this, and everybody can remember what it means or imagine what it means, but not enough to code actually the things down. So you need your customer afterwards to ask what he wants and do all the test stuff.
So requirements engineering means you have some people, on-site customers or proxies of the on-site customer or whatever way you want to implement it, and they sort of take index cards, writing sort of memos for that only they really understand, that give markers for them to explain in more detail later, and then they put them in a cardboard box, and this cardboard box is sort of the requirements document.
Exactly. And these cards will be taken out by developers afterwards. We will touch this when we do discuss the planning game, and can be brought to your desktop when you use the task. So they are more than just a requirement document. Actually, they are an artifact to the heartbeat of the project, as called. So you use it as a token to drive your project, actually.
So we'll go into more detail when we're looking at the planning game, but just to give a short idea to put this in context, the developers or these cards are prioritized by the customer for the iterations, and then the developers ask for details on the most highly prioritized cards, and then they estimate them, and then there's a negotiation which goes into this first, into this iteration, and only one iteration is planned in advance, basically.
Exactly. And afterwards, the cards are getting
or
thrown
pinned on the
away or
wall
whatever.
to show how much work got done or whatever. Okay,
Exactly.
but we'll go into more detail later. But you said it was heartbeats. I always thought the iterations were the heartbeat, which actually is the next practice.
Yeah. Depends on your picture of heartbeat.
Actually,
the iterations are the metric, the beat or the timely beat. Yes, for the process stuff. But the stories are the driving factor. Without stories, your team gets no more things to do. So actually, that once happened to me in a project. I worked in XP project where we had not an on-site customer, but our customer or the guy who was in the on-site customer role actually hadn't had the time to do new stories to get new input, and our project actually ran dry. So it's the pushing factor in XP.
Yeah,
that's why I
I was just joking because it is not obvious. Yeah. It will become obvious when we go into the planning game, but it is the heartbeat. Yeah.
Yeah. So, you touched iterations. Next primary practice are the weekly cycles, so-called, which are the iterations, where you do all the stuff you usually do in a huge project. You do the planning, you do implementation, testing, really. So the whole iteration cycle usually fits into 1 or 2 weeks. Depends a bit on taste, how long it is. But it's called weekly cycle.
But the idea is to actually have deliverable software at the end of the week. So it's not just hypothetical, but you actually burn a CD or whatever and give it to whoever is interested in it to receive feedback.
Yeah.
So this is actually releases. It's not just hypothetical labels on the versioning system. It really is an integrated, tested release that is given out.
It's a complete project, if you want, a complete cycle that you do, a complete release, yes, every week.
How much overhead does this sort of release involve? I mean, I've been in projects where the overhead of getting a release done was several weeks all by itself. So how much overhead does that involve?
Yeah, that actually could be a problem. Not so much because of the overhead on the team side, because usually when you do an XP project, you do everything you can do releases in a simple way. So everything in an XP project is focused to make things automated. You have your unit tests, so you don't need a long beta or whatever testing phase before you can release it. So everything in XP does it or tries to make these simple releases or not so costly releases. But the problem often, or at least in my past, was that the customer isn't able to handle this. Even if you do 2 weekly releases, not so many customers have the time to do tests on 2 weekly releases. So actually, I had some problems in the past.
Yeah, but I think even if the customer isn't able to handle this release, it's still valuable because it helps to focus. It helps to stay close to having a releasable software. It helps to think about small steps that lead to incremental value and to divide the work into little things that do not break anything big.
Absolutely correct, but it's tougher to get a team to do a real release every week if no one cares for it. So there was some problem for me. And yes, you're right. It's not just for getting feedback from the customer. It's important to a lot of integration work as early as possible, because otherwise you get a huge heap you have to do sometime at the end of the project. So doing releases every week is good for the project alone, even if feedback isn't the necessary point here. But it's tough to get a team to do it regularly. Or so often when no one really cares for it.
Exactly.
Outside of the
team. One more word of caution here. In my experience, this release does not have to meet all the usual criteria for a release. Usually, if you actually do a release, there are, let's say, data migration requirements. and which take effort that usually is not necessary for every single of these weekly releases. They're just sort of to give the customer a hands-on feeling. And also, in my experience, these are not as thoroughly tested as actually final releases need to be. They are just to show the customer the direction the project is going in. So if it is less stable or not as well integrated with other systems as is desirable and needs to be done in the end, that is okay for this sort of releases, just to keep the overhead low and enable rapid feedback.
Mm-hmm. Okay, but besides these weekly cycles, there are also the quarterly cycles, which are not so much iteration cycles, but you have to do the, call it higher level management stuff. You have to plan your real releases for customers, or if you have a product and not a project, you have to do marketing stuff and plan all this stuff. You have to plan resources, people, timetables, all this stuff. And, that's done in a somewhat quarterly, cycle.
Sort of to get the sort of thing done that needs to be done long in advance. In the everyday work, you don't want to bother with thinking ahead and planning long ahead, which is part of the XP philosophy way of doing things. But sometimes you need to do that. So once every quarter or at whatever frequency, you sit down, take the time to really think ahead and sort of try to guess the future.
But still, it's important to mention here that the detail level is different from what other development processes do in this quarterly cycle. So you don't do detailed timetable planning, what some guy does in 3 months on a daily basis. That's not the idea. The idea is get the big picture actually, and afterwards you have to correct your maybe false plannings anyway. So it's really the high level stuff and that's necessary to keep a company flowing. So I guess that were the big the cycle stuff, the time stuff. We have some other primary practices to discuss that are not so well related, or I don't see a common topic. First one is Slack, which is the idea is simple. Just plan Slack, because you need it. You need to clean up your code. You need to place around. You need to do research. You need to learn stuff. So you have to plan in Slack somewhere. I'm not sure how this was handled in the first edition of XP, but I guess there was no Slack actually.
I think we went into this in the first episode when we discussed pair programming, and actually that is where it is in the first episode, because pair programming tends to keep you busy all the time and tends to put peer pressure on you, even if no one really expects you to focus all the time. You sort of want to impress others by not being the first one to say, I need some time off. So, this is closely related to pair programming, I think, and you really need to create a culture where it's okay to say, I need some time to do my emails, I need some time to do research, whatever. So actually to allot whatever number of hours to encourage people to actually take this Slack.
Yeah, but actually, also for the higher level stuff, not only the 10-minute breaks while pair programming, the second edition of the book actually says you have to plan for timeout and stuff like that. So, it's also on a higher level.
So someone might say, I need to do research, I'll be back next week.
Give me a month. Yeah, exactly.
Yeah, exactly, yeah. I mean, this sort of thing actually happens without XP, and in XP you really need to make it explicit to encourage people.
Yeah, exactly. So, next practice.
This is really one of my favorites.
Mine too. I have a lot of trouble with this right now. Okay, what's the idea? You have to set a marker how long your build might take, and every time you go beyond this time limit, do something to get below again. So the idea is, and this timing level is mostly there's no real rule how to find it or where it has to be. But
the rule of thumb that I like to use is developers need to feel comfortable with it. The build, people should not feel that the build gets in the way of getting things done.
Yeah, exactly. And a 10-minute is a good, good idea where a limit is, where a team gets into trouble.
Yeah,
there.
Actually, I would place the limit a lot lower. Somewhere from 2 to 5 minutes is my rule of thumb. But anyway, this obviously varies from team to team.
Yeah. And one problem here is, of course, that's very dependent on the technology you use. That is one of the things, you can do, when you use stuff like Smalltalk or Java or C# or whatever. My project right now is a huge C++ project, and it's very hard to do it, below 2 hours.
Right, yeah. This is, but this is sort of a problem of C++.
Yeah, exactly. So, you see some of the techniques are actually even technology dependent, in XP and come from the background where the guys, worked before. They did Smalltalk, they did Java. Of course they did C++ projects too, but their main focus is on these techniques. So you might get into trouble with some of the techniques in different environments.
Yeah, but let's take a look at what this 10-minute build really is about. I mean, the idea is that every developer is able to perform a complete automated build on her own workstation regularly in order to execute the tests, and executing the tests is part of this build. So the important thing is that people don't just use their IDE to there's a bug over there, but I'll just ignore that. It's very popular with people who use Eclipse. But actually everybody is able to do a real build, to execute the build script that actually goes into the production build as well, and execute this build script which compiles everything and also executes all the tests on a regular basis. This is sort of an enabling technique for rapid integration, especially for test-driven development.
But what can I do if I can't do it simply? I mean, as said, C++ takes some time to compile, and computers are as fast as they are now. And if my build right now takes 4 hours, okay, maybe I can optimize it to take 2 hours, but 10 minutes is way out of focus.
But there are techniques for C++ that speed up your build. For example, decouple the system into several compilation units, and then decouple the builds and check in the results of the compilation into the version control system, so that you only need to recompile the compilation unit you've actually made changes to, and link it to the checked in compilation units of the other compilation units.
Okay, so your answer is actually do whatever you can to get to a short build integration.
Exactly,
build.
Yes.
Because I mean, there is a lot of effort, and I know projects where even the linker run takes longer. So nevertheless, you say do everything you can to get there.
I would say that, and otherwise, eXtreme programming is not the process for you, I would say. But especially keep down the time as far as you can, because otherwise test-driven development will not be done. Because you need to build the system in order to run your tests. And if building the system takes 2 hours, you just will not run your tests after every single change. But we were getting to the next practice, actually, I think, which is continuous integration.
That's what I wanted to say. Exactly. Well, I think a lot of what we said for the 10-minute build, fits good to the continuous integration topic. The idea is, of course, to integrate as soon as often, even continuous, as possible, because the cost of integration grows over time exponentially. So the idea is to do it as soon as possible, get feedback as soon as possible, and that's why we taught so much about the 10-minute build. To do this, your build needs to be fast, because anytime you want to check in, the idea is to get an integration build as soon as you check in.
Yeah, this is
immediately.
sort of the ideal. There are tools in different languages, for example, cruise control for Java that does just this.
Yeah.
It's coupled to the version control system, and every time someone commits a change, an automatic build is started, and if it fails, mails go out. This is sort of the high ideal.
Yeah, exactly. And if you take a look at the higher level, the basic idea is the same with the weekly cycle. I mean, even the weekly cycle with the weekly release is some kind of the idea to integrate as soon as possible, to get feedback as soon as possible. Same idea here.
Exactly. And taking your comment, going back to your comments about C++, I have numbers from the 90s, that even the people at Microsoft working on Windows NT did a complete build every night. And so obviously this probably took more hardware than just a single workstation. But even there, they did this continuous integration as continuously as was possible, which was every night. And they ran what they called smoke tests, in some little test suite that showed if at least the rudimentary functionality worked. So this is possible even for huge projects done in statically linked languages.
Yeah. As far as I know, they kept they did the same thing. It just wasn't 10 minutes. They set a time limit and they kept their build under this time limit for a very, very long time. Don't know if it's still true, but it worked for them for a long, long time.
Yeah. Well, I think this is one of the practices that gets discarded quite frequently, actually, because it's so simple to sort of just ignore this. Oh, the build broke, I'll just fix that later. So this requires discipline and requires backing by management in order to keep things going, to keep this practice alive, especially in the beginning. And the problem is, I mean, you've probably been in this as well. There's this sort of thing I like to call integration hell. You've been working on a project for a couple of months and have different people, different small teams working on different parts. Communication didn't work too well. And then a month before the final shipment, you sort of throw everything over the fence to the central build and integration and test team, and things won't even compile. And after 2 weeks, you get them to compile and find out nothing works together. And this is really hell because it's very, very difficult to fix. This is the exponential thing you mentioned in the beginning. Different parts of the system don't initially, or oftentimes they don't initially fit together exactly. And if you find that out after 1 hour or after 10 minutes or whatever, it's very easy to fix because you still know what the problem might be. If you find out after a week, it's hard to fix because there are so many subtle dependencies that were added, and it's hard to find out which part causes the problems. And after a month or so, it's basically impossible to really fix. And it's a huge effort that needs to go in there. So the idea is to keep the different parts together, to avoid giving them the chance to go in different directions. And this is really, really important to do, even, and if your system is so big that you can't do it really continuously, do it at least every night. And if you didn't do that so far, you might want to start by doing it once a week, but with the goal of getting to once every night. This also goes back to other practices, working in small increments, because if you want to split your changes into small things that can be integrated and then tested in the integration.
Exactly. And if you remember back our first XP episode, you see the value behind is feedback. I mean, it's you can take all the practices we discussed right now and map them back to the values. I guess maybe it's getting more understandable the value discussion from the first episode if you just try to map the practices and the values sometimes. So let's jump to the last primary practice, incremental design. Which is,
I think it's one of the most controversial practices of all.
Okay, what's the idea? The idea is to postpone any design decision to at the latest responsible point in time. You don't do a big design upfront in your project, you do it as late as possible, actually. So, just when you get in your new story, your new user story, and it does need a change in architecture, in design, do it when you need it, not front up, just when you know, yes, I need it right now, not anything in it.
I'd like to illustrate that with a little story, which is about Kant. I mean, this practice and how to interpret it was controversial among the different XP people. But I read somewhere that Kent Beck said that even for business systems, he would not start by saying, so when we start the system, we know that we will need a relational database, but postpone even such fundamental architectural decisions until you really found out that you did need a relational database, which would obviously be quite early usually, but still he would not start with this assumption, but have even such fundamental assumptions be driven by the actual development process, by feedback.
I guess that gave some discussion.
Yeah, some of the other XP people said they wouldn't go as far as that, but that's the idea, to sort of step back and leave behind assumptions that might or might not apply to this system. Because in the beginning, the idea is, you don't really know much about the system, and some systems sound like like a relational database is a good idea, but later you found out it isn't. And then, you might want to take it out.
Yeah. And the idea behind this, of course, is the experience shows that you do a lot of things in advance you don't need any time in the future. So a lot of people, architects, developers, project managers, whatever, everybody adds his part there to make systems more future safe, or how would you call it? And actually, it's much more effort put into making things in advance that doesn't get needed anytime in future than it would take to make even hard changes in architecture when it comes, because the system is much smaller if you put out all this stuff and just do the things you really, really need.
Yeah, exactly. The idea, or one of the drivers behind extreme programming, is to make changes easy, to make changes cheap. And you get the best benefit out of this cheapness if you don't spend the effort to design up front. I mean, you can do that. It doesn't do much harm usually, or it might even do harm. But anyway, even if it doesn't do harm, you don't have much benefit from it, because making the changes later isn't very costly. So the idea is, in the beginning, you don't really know if you need a relational database or not. For some systems, for most systems that have a relational database, I'd say you know that upfront, and that's okay. I mean, you don't have to discard all your experience, but just stay with this example anyway. Let's say there's a system, you don't really know if it needs a relational database, so you start out one way or the other without spending much time analyzing all the requirements that might come up later. You just start with a system, and once you find out that your initial decision was wrong, that's fine. You just change it then, because that's cheaper and gets the overall job done better and faster than if you had spent the time in the beginning to think about this. This is the idea behind extreme programming. Refactoring later.
And actually some of you might know this cost of change curve that will get taught in the universities and is printed in a lot of books, which basically says the later you do a change, or you find something to change, the more it will cost. And this is not linear, but it's exponential. And the idea of XP is here to keep this curve as flat as possible, to make change not costly in future. And when you have done this, and it's done through unit tests, through pair programming, through this incremental design stuff, you can work completely different in your project, and other techniques do work. So one of the very basic assumptions is to change this cost of change curve actually. Otherwise, it wouldn't work.
Exactly. So all these practices play their part in, the traditional curve is exponential. It's like, if changing something during analysis costs 1 unit of money, it's 10 units of money during architecture, 100 during design, and 1,000 during implementation, that sort of thing. And the idea, the claim that Kent Beck makes for extreme programming, that this curve is flat. The cost does not vary. It is just as costly to make the change during development as it would be during analysis. Okay, so what you say, we just do a walkthrough of an XP project. So let's say we are approached by someone who says, build me a system that helps me sell things through the internet. And we are an XP shop, or we want to do things the XP way. What do we do?
First thing here to mention is XP is not just a programming team or process thing. It even influences the way, or it massively influences the way you interact with your customer. So, what you don't do, let's take it this way, you don't get a contract or do a contract with the customer where is exactly written down what he wants at a fixed time point. So, you have to explain your customer that you're an XP shop, that you work with him together to find or to build the solution actually, that his involvement is important and that you only can be successful if you build your software together. And he has an important part here. You both do risk sharing here. It's not fixed price contract, whatever, however you call it. It feels different for the customer. And, actually, even if XP became more common in the last few years, my experience is you still have to explain your customer that it's that way, and because he usually has no experience doing projects.
So one thing you were saying is XP means it's not a fixed price project, but actually sort of it's an ongoing thing, time and material payment. And at some point in time, the customer can say, okay, this is enough. I don't want you to go on, and I just take what you have now.
Exactly.
So this is quite interesting because oftentimes customers want to know how much things cost in advance. They need to allocate their budgets, that sort of thing. How do you deal with that in an extreme programming setting?
I don't want to discuss it in depth here because it's actually a really complicated thing. Easiest way is to of course do time and material project, but that doesn't work for every customer. There are actually different kind of contracts you can do that works. You can the customer can fix a budget, but then you have to the requirements are not fixed. You have to leave one of the key drivers of the project open to make it possible to reach your goals. So complicated issue. A lot to read on the web on this, even contracts, sample contracts, how to work this out. But maybe a bit too much for here to discuss this.
So the idea is it works best with time and material, but there are different models. You can read it up on the web. And I mean, obviously, if a customer approaches us, we can give him an estimate of how much it will cost. It's just that this is not a binding estimate because the requirements are not binding. So it's sort of like a trustful relationship. We give the customer an honest estimate, and the customer trusts us that this is an honest estimate. So it's based on trust.
And when you take this first step, which is usually the hardest because if you don't know your customer, this trust thing is hard, of course. When you're really on the project, usually a customer gets a feeling that you have a trustful relationship because he is on site with you actually. He has guys in your team and sees how you work. So, this is usually really a startup problem, but it might be a hard startup problem actually.
Okay. So let's say, we estimate it will take 3 months and cost you, 300,000, euros. So what happens then? The customer says, "Oh, great, that's my budget.
Okay.
That's fine with me. That meets my deadlines."
Yeah. So what we've done here is actually our quarterly cycle. We had this overview planning, this rough planning. What comes next is we really jump very, very fast into our weekly cycles, into our iterations. So
basically, we sort of get together our team of 4 people and say, here's your room, decorate it any way you want, create your own productive atmosphere, and get started.
Getting started means you write your first user stories, your team and your on-site customer, and that's maybe we should go into more depth here right now. But your team and your on-site customer sit together in the room and work out the first set of user stories.
So actually, at the moment, when the contract is made between us and our customer, the other company that gives us the contract, there is no fixed set of requirements that anyone had to agree on. That is sort of postponed. We sort of say, okay, we've got a rough idea from one meeting, let's say, and then we want to get going, and for that we need user stories. How do we get those, and who is this ominous on-site customer?
Okay, let's start with the on-site customer. Often discussed point. The basic idea or the first explanations were it's a guy from your customer who knows how to, or who actually works with the software afterwards. That's important. It's not some manager from there who tries to guess what the software needs. It's a person who actually has to work with the software afterwards. So he knows what really is important from business side, but he also needs the competence to make decisions. What comes in, what doesn't come in. And this is already very hard to find. Someone who works with software has the competence to decide and knows every aspect of the software. So, one of the things that's changed over the years with XP is it doesn't have to be one person. It might be a team of persons for different aspects, and that's still the important part of it. He or the team has to be on site with you. He is actually the whole day with your team in the team room and works together with you. He does tests, functional tests. He does user stories. He does prioritization of user stories, whatever. But he is actually there. He is not someone in a different company where you can call him. He has to be on site.
So this
with
is
you.
actually one thing is that you have someone on site in the same room who is empowered to make binding decisions for your customer, and who is also an sort of expert who really knows what the system should feel like, so that those decisions will actually be sound and actually be supported and lead to a working system. And the third thing, what I understood is this person or group of persons should be on site, become part of the team, which is a huge step of building trust between you and your customer, building trust in both directions, so that your progress will be visible, your approach to things will be visible, and also you will have the benefit, or we will have the benefit of actually receiving quick feedback and receiving quick decisions. So we have this. Let's say we have one on-site customer. We have a company we're working for is ideal. They actually send us one of the end users. And this person is on site with our 4 people.
Okay. So the first thing they do together is write user stories. So they get some cards, index cards, and the on-site customer ideally writes the most important user stories down on the cards. He writes just a bunch of them down on the cards. And tries to, of course, write the most important. Of course, in XP, as you have this idea of saying or making it possible for the customer to say the project is finished now and all the important stuff is in, and the stuff that now isn't implemented is not so important. So you prioritize your user stories by business priority, whatever that means, by value for your customer. So the idea, of course, is that the on-site customer writes down the most important stories to him.
So on day one, the team gets together and starts discussing things and writing down user stories. How much time do they spend writing these stories before they actually before they boot their computers and start coding?
Okay, I guess as we really started first iteration here, and team and customer don't know each other, it takes longer than usual. Usually, it would take just a few hours, so maximum a day. But as it's the first time, it might be a bit longer, of course, because you have to get known to each other and stuff like that. So
okay, but it's really short. It's not spending weeks
really
in
short
upfront analysis. So the idea is to get started coding as quickly as possible.
As said, a few hours maximum. So, of course, this is not, it sounds a bit simple. It's not that simple in real world that the customer sits down and writes his story and the developers sit around him and watch him writing. Of course, it's a dialogue. He explains what it does mean, that the developers get an idea what this story, as said, it's just one or two sentences actually mean to him, what he really wants when he says calculate rate or whatever. So it's a discussion here.
Okay, so let's say after 2 days we have our first set of stories, and these stories are, and our on-site customer says, okay, this set of stories is sufficient at first. Let's get started with them. So what happens next?
Okay, the developer give rough estimates how long it takes to implement a story. So you give them the cards, or the customer gives them the cards, and they try to figure out, to think about how long it simply takes to implement these stories. One interesting point here, of course, especially when you do it the first time, you think in days or real days or whatever. One thing is to mention here, important thing is that that your estimates are relative. So you take your first card and say your team says it takes whatever 1 day. Let's say it takes 1 day. So you take the next card and you get a more precise estimate usually if you not just think about, okay, I think it takes 2 days, but you compare both stories. You estimate relatively. So you look at your second story and say, oh, I guess it takes double the time from our first story. So usually you get a better estimate this way. Very important, we will see in the next iteration why these relative estimates are important. For the first iteration, it doesn't make that huge difference, of course.
But what about the basic infrastructure that needs to be in place before? I mean, the on-site customer probably won't think about setting up the Surflet engine. Let's say it's a Java project, setting up the Surflet engine and getting all the basic plumbing in place. That probably won't be part of any of the stories and needs to be done before for every single story that the on-site customer wrote down, probably.
Again, depends on your start position. Usually when you're a project shop, you have a lot in place. I mean, build, environment, all that stuff usually is easy to set up. If you're completely new to business, it might take some while to set all these things up, because there's a lot, as you said, test environments and server engines and whatever.
One thing is the actual infrastructure, but then I meant the specific code, like being able to sort of creating the database table, the operational relational mapping layer, whatever. That sort of thing is probably not visible in any of the user stories and needs to be done before anything that is of actual business value can be done.
Yeah, and that's a completely different thing from these first time startup stuff, because as said, we have an incremental design where you have to change your architecture and develop your architecture on the fly all the time. So if you have normal additional effort for building these kind of infrastructure, servlet engine integration, whatever, you estimate it together with your story. It might be that there are very, very huge, and huge means as large as a normal user story is, things to do. For example, it takes a day to whatever, install a servlet engine and set it up correctly and integrate it.
Create the basic infrastructure classes for customers and for products, and create the object relational mapping layer that actually makes them available for the business logic.
That's I have a few problems with this one. First, if the list was too long, I don't think it's a good way, and maybe this is the link back to the discussion upfront design from
exactly. That's what I was getting at.
So I wouldn't really do a complete infrastructure setup with the first feature.
So let's say let's get maybe concrete. Let's say the user stories go something like this. One user story that is really important is enter a new product into the product database, sort of administrative work, and the other thing is allow an end user to view the list of products with their prices in the browser. Let's say those are the two user stories that were prioritized most highly.
Okay. I would say for the first one, I would say, it's, if you estimate it, you will discuss all the things you mentioned. I need a servlet engine, whatever, all the points. And, if you put all the estimates in, your user story gets too large. So you break it usually up. And if you afterwards have two user stories, you have to take care that your user story still, so basically what you do is, introduce a new user story for your whatever database setup, for example.
So you create sort of technical user stories and explain to the on-site customer that these technical user stories need to be done before any of the original user stories can be done.
But, and that's why it's so hard actually to explain. First of all, always write it in customer language, I would call it. Don't say, I need a relational database with an UR mapper or whatever, because the customer doesn't know what you mean. He doesn't see any value in that. So always describe it in sentences that your customer actually knows what's the benefit for him, because afterwards he has to decide if you will do it or not. So if it's something like, I will introduce Hibernate to our mapping stuff, the customer will not choose this user story anytime. So that's not really good. Just describe it in
How would you do that for these stories, for these things, like getting the infrastructure code written that you need for getting the basic architecture in place that can support the other user stories that you start with? How would you phrase that?
And that's the second important point I already mentioned. I wouldn't do it all in one story. I don't think it's good to have all infrastructure in one story. You have to. I don't think any feature that is small enough to get through as a user story should be that large, because afterwards you implement all your architecture front up and just the business stuff afterwards. Usually you can get away and implement some feature just entering it in a web mask, for example. You don't need the database right now. Second thing, you make the thing persistent. So split it up into smaller parts that still give customer value and explain what the value is. So introducing your relational database, for example, gives the customer the value that the entered product, whatever, is available the second time he logs in. So split it up in business perspective, not in technical perspective. and don't do all the infrastructure stuff front up. You need some stuff, of course, as said, build environment and all these things are different kind of story. But the usual business stuff, you shouldn't implement all this front up, because then you have this big design up front, even worse, you implement it.
Okay, so we have the initial set of user stories, and they were discussed with the developing members of the team, and there are some stories were added with the wording of the terminology of the customer.
Yeah.
And then the customer makes the decision which of these go into the first iteration.
Exactly.
Based on the estimates.
As said, you split, you maybe even merge some user stories if they are too small there. Tracking makes sense. So you have your file set, and afterwards the customer, and only the customer, has the right to decide which stories go into your iteration and which not. Takes the cards, and you have estimates. And the first time you usually get or start with something like days or whatever, time efforts. So you can calculate how many of the stories you roughly want to do in this first iteration, and the customer actually he sorts them by priority. So you get away from the problem. I mean, I'm sure you too have this problem sometimes, that you have 200 priority 1 features to implement and non-priority 2 features. So bring them in the actual order, or the customer has to bring them in the actual order how to implement them.
Okay, so now we have a list of user stories that should go into our first iteration of 1 week, and then we actually start coding, splitting into pairs, and start coding, writing our tests, emerging the continuous build, and at the end of this week, we have sort of finished, let's say.
Exactly. Just to mention the name, what we discussed right now, the splitting of user stories, the estimation, and the prioritization is called planning game in XP terminology. So yes, you do first the planning game, then all the development with all the practices we already discussed, test first the development, and at the end of the iteration, the 1 or 2 week iteration, you should have, and that's the rule, so you must have running software that fulfills the stories that your customer prioritized. So what does the customer do? Of course, in these 2 weeks after prioritization of the user stories, testing, simply. Anytime you get a feature implemented, the customer has, first of all, he does interactive testing, but also if he uses some test frameworks like Fit, for example, he can do, with the help of a developer, maybe automated acceptance tests. So what do we have? We have a complete run in an iteration. What needs to be done additionally, all the, after iteration works, so-called. You have the release. You have now the possibility to calculate the metrics. You have a number of stories implemented. Let's say we have 4 stories implemented. You have the estimates, the initial estimates, and with all these information, you can roughly estimate how much or how many user stories you will able to do in the next iteration. The idea is called yesterday's weather. You just look back and see, I don't know, in 1 week, we can do the work of 3 estimated days, for example. So next week, we usually should be able to do the same amount of work. That's how metrics or speed is actually, team speed is calculated and used to estimate how long your project will take. So we now have a complete run through an iteration, how it works, and what happens next? Well, next iteration. So we start again with the planning game. We now have all the information from our previous iteration, so we know how many stories will fit in an iteration, how the team works together. All gets a bit more fluent, and it gets better by time. And that's also true for the metric stuff. The more iterations you have, the better the speed is actually. The more reliable your speed estimates are on this way.
So we have one iteration, and then the next, and then the next, and then the next. When is the project actually finished? I mean, there's always some new wishes, some new user stories.
Exactly. Very simple. When the customer says it's finished. So when you're running out of stories or important stories or stories not important enough that the customer wants you to give money to implement them, the project is finished. And that's one of the great things for your customer, actually, when you have to sell XP to your customer because it's a lot more work than usual projects. He just has to pay exactly for the things he needs, not more, not less. So very great thing actually for a customer here.
So actually the customer can pull the plug on a project anytime he wants, sort of terminate the contract at a week's notice, that sort of thing.
That's at least the XP perspective on this thing. I mean, in real life, you usually have contracts and stuff like that. So you would handle it a bit different in most situations. Nevertheless, in theory and from XP perspective, yes, that would be the way it goes.
So we talked a lot about how to get buy-in of a customer for XP. But that's only one of the groups you have to sell XP to. The other group is the people inside your own company. So let's say one of our listeners wants to get XP started in their company. How do they get it? Do they get buy-in? How do they get it started?
Buy-in is a lot of political stuff. You have to know all the advantages of XP, and there are a lot. I'm actually a huge XP fan, so I'm really convinced that XP is one of the best development processes right now. So just learn the advantages of it and learn how to sell it. How do I start XP? Well, the best idea, in my opinion, still is get someone who really did it before. Nothing can compare to this. No book reading, no podcast, nothing comparable. You need someone who really has done it before, because it actually is hard to implement. Even if it sounds very, very easy, it is hard, believe me. Next thing is, if you have someone or not, I hope you get someone who really did it before. Test if you really can deal with test-driven development and pair programming, because that's not everybody's thing. I mean, especially pair programming is a hard thing, and not everybody likes it. And so test if your team or your peers and you do really feel or get comfortable with pair programming and test-driven development. And then the practical stuff, just start with the user stories. As simple as that.
So if you don't get management buy-in, you're one of the things that I found with experience is it sometimes actually works to just do it without the explicit approval of management. If you're convinced that it actually saves effort and increases speed and increases quality, one way to do it is just implement it. Start doing it subversively. And then after a week or two, when management notices, you can have your first results that you can actually show.
Yeah. Can work, but on-site customer is always a problem there. You need a customer that helps you here. And if your management and your customer are the same person or same whatever, you might run into a problem here. But yes, I would agree. And a lot of the XP techniques are really can be factored out, but nevertheless know what you do. As said, global code ownership without unit tests can be not a good
unit
idea.
tests are basically the foundation for unit tests, and refactoring is basically the foundation for all the other practices, I think.
Yeah.
But speaking of the problems with the on-site customer, I think we are getting to the problems that you might run into, problems and limitations. And I think having an on-site customer is, certainly it's difficult if your management does not agree, but is generally a problem, I would think, to get someone who's actually an end user, to get them to spend 100% of their time in your one room together with the software team and work on this project. For most customers I've been working with, this would just not be an option.
Yeah, and not only he has to be all the time with your team, he has to be competent, he has to know what to do, and he has to have the rights to decide what to do. So, that's, unfortunately, that's so seldom. If you think about it, it's strange that it's such a huge problem, because usually the customer should have, should have the pressure to get a result from you, and should want to get engaged to all this stuff. But, in practice, it's a huge problem. I would say the hugest problem.
Yeah, I agree. And I think it's much of the reason is the culture, because for decades, software has been developed differently with communication through documents, that sort of thing.
Yeah.
But I think one thing that actually works quite well, although it is not XP in the strict sense anymore, is to have some sort of proxy for the customer on site. The sort of lowest profile approach would be to have one member of your local team be the person to communicate with the customer, spend time on the phone, writing email, maybe even reading the specifications that are there in writing, to sort of build up knowledge, and then also be the person to negotiate decisions with the relevant people at the customer side. So this person would then become a proxy for the actual customer and take the role of on-site customer. It's not quite as good as having the actual person who makes the decisions on site, but it's a workable approach if you just can't get someone. Yeah.
And maybe one idea to add here, you could argue that XP makes this thing explicit, but how could another development process really work without something like an on-site customer? So I guess it's really an usual problem to any software project, and just because XP really states it, I'm not sure if it's worse than a different or other development process here.
In a way, you're obviously right, but then other processes address this problem in different ways. For example, by forcing people to actually spend time thinking about their requirements. And of course, those requirement documents will never be perfect, but they usually give you a better understanding of the actual things that need to be done than just writing user stories up front. So,
yeah, but you need time too for this.
You need time, but it's much easier to get the specification documents than to get an on-site customer. Those are just two different approaches to solving the same problem, and the on-site customer is the solution that leads to better software, and at least that's what I'm convinced of. But still, writing the specification documents is the usual approach that customers are used to.
Okay, next problem from my side, all the social aspects, pair programming, all this stuff. I often heard XP just works for senior developers who are really great developers, because they have to know everything to do design on the fly and blah blah blah. But in my experience, that's not the problem. The problem are the social aspects. Actually, the people have to communicate in a different way, have to communicate all the time, have to feel responsible, have to take responsibility for stuff, act proactive, do peer decisions, all that stuff. It's not, technology is not the problem. Programming is not the problem, actually, in my experience. All the social aspects are really, really difficult. And if you have the wrong team here, you might end up in a disaster.
Yeah, I agree. One variety of these things that are one of these reasons that is often given against XP, against pair program, that sort of thing, is I mean, in XP, every person works on every single part of the technology. So every person works on the database code, if there's a database. Every person works on the graphical user interface code. Every person works with XML, and whatever. So I heard people say that this means everyone needs to be an expert on these things, which is also really not true. I mean, obviously you need to have at least one person on the team that knows these technologies you're going to use. Otherwise, you're in trouble anyway. You need to give people time to learn it, whatever. So let's assume you have at least one person for each of these things. Then the usual approach would be, if someone wants to do some work on the database, to just get this person who knows the database and pair up with this person. So actually, it works very well if people are not senior developers, because it helps to spread the limited knowledge throughout the team, to help people to learn from one another. Even if, I mean, it's always difficult to develop software if you don't have any senior developers. If you have no one with experience, you're in trouble anyway. But even then, XP would help, because there are two people thinking about the same design decision at the same time, and if one person feels unsure about this, they would discuss it, and so you would have a team that is comfortable with the design you're having. So the whole team is comfortable with the whole design, knows the whole design, that sort of thing, and refactors things. So even in such a situation with no single senior developer, you're in you're not out of trouble, but you're in less trouble than you'd be with other approaches.
Yeah, absolutely. So, anything else to add?
Well, there's one prejudice against extreme programming that I would like to talk about, maybe to wrap up the episode. And that is that extreme programming, well, actually this is often said about agile development as a whole, that extreme programming is just hacking. Extreme programming is just like, oh, we don't want to spend time writing documents, doing testing, all these things we don't like. Let's just get to the keyboard, let's dig into the code and do some hacking. And this is really a prejudice that has given agile development quite a bad name. And I think this is a huge misconception, and it's very important to address this at the management level if you want to do agile development, because if a project goes wrong, I've heard managers sort of joking about saying, oh, we're doing it agile now. Meaning we've left behind all sort of organized process. No one knows what's going on. And this is just...
we don't do any documentation.
We just left all the documentation and the planning and the testing and anything. And this is a huge misconception. Actually, extreme programming is the single most disciplined process that I know. It requires very much, it's very strict. I mean, if you do extreme programming, there's no line of code that goes into the system that was not reviewed by a second programmer. In extreme programming, no code gets written unless there's a user story for this code and the customer prioritized it, saying this goes in. If you do extreme programming, means that write no code, or well, basically no code, that is not tested by a unit test that is run continually by all the developers. They're run many times every day. So it's very, very disciplined.
Not only there, extreme programming also says just on a minute basis what to do, when to switch keyboards while pair programming. It's really, really tough. I mean, most other methods just say, do your coding.
Right.
And not anything more.
Well, they say,
it's really
and write
detailed.
these 24 documents afterwards.
Yeah, exactly. So it's really detailed, and really it needs discipline.
Right.
Very much
This
discipline.
brings me to one thing I'd like to add, and that is a prejudice that in extreme programming and agile development there is no documentation. Actually, this is nonsense, because the customer can write a user story at any point in time saying, I want documentation, and then of course you write documentation. So it just makes it explicit that this takes effort, and the customer decides how much documentation the customer wants. Just as an aside, I think this is one of the other prejudices. But getting back to this thing about hacking and programming, actually, extreme programming is very disciplined, but this prejudice shows how important it is to actually do it wholeheartedly. If you just say, well, I'll do the planning game, but pair programming and refactoring and unit testing are not for me. You'll be in loads of trouble. And especially unit testing. We'll get back to this again and again and again. Yeah. Unit testing is the most fundamental practice. And, well, it goes together with refactoring usually. So refactoring and unit testing are the single most fundamental practice on which everything else builds. If you don't have that, nothing will work. So, actually,
there's one true part to this prejudice. I think extreme programming is much more code-centric than most other development processes. It's much more focused on the actual stuff that gets to the customer, the real code actually. So it is much more coding-centric, hacking-centric, if you want, than other processes, but that doesn't mean it's not disciplined.
Exactly. It takes some switching of the priorities of the approach to programming in the developers. I mean, one thing is giving up code ownership, sharing responsibility for every line of code. Another thing is to learn to read and write unit tests, which brings us to the episode on unit testing we're going to do, which is really, really important. But this is a different approach if you want to understand code, to not expect there to be lots of documentation documents that you can read. I mean, it's okay if they're there, but they are often outdated anyway. So, it's a skill that actually needs to be learned. It doesn't take very much practice, but it takes some practice to read good unit tests in order to understand what code is about. It also means that you need to clean up the design continuously for the code to be understandable from the code itself, from the unit tests, to have good names. All these refactorings are important. If you leave them out, the code won't be understandable and you're in trouble. But if you have good unit tests and good names and good structure overall, then it's not very difficult to extract the architecture even and the design from the code itself, especially if there is a team the whole team knows about the design decisions and the trade-offs involved, and everyone is familiar with different parts of the system. So these things work only if you take the whole bunch of them, if you actually do unit tests, if you do refactoring, if you clean up things, and if you avoid code ownership, and because you share responsibility and knowledge of the code with all developers. But if you do these, then actually XP isn't far from hacking. It's quite the opposite. Actually, it means that everyone takes responsibility for every change and people work together. And there is good documentation in the form of knowledge that is spread and good unit tests and good design.
Okay. So, as we are already have one of our longest episodes, I guess we should end here. Anything else to add?
Give XP a try and give agile development a try, but especially XP. Start with unit testing, refactoring, and if you're familiar with that, go to pair programming and add the other practices. Give it a try. It's a great experience, and it really brings a team together. If you get the chance, do it.
Yes, I hope we didn't keep you away with our too long episodes here. It's not as hard as it sounds here.
Definitely not. Yeah, well, I think this about wraps it up. Thanks for listening, and hear you next time.
Thanks for listening to Software Engineering Radio. If you want to get more information about Software Engineering Radio, or if you want to give us feedback, please go to our website at se-radio.net. You can also contact the team at team@se-radio.net, although we prefer entries in our comments system on the website so other people can see what you think. Software Engineering Radio wants to thank Henning Pauli for the intro and outro music, as well as Libsyn for providing the bandwidth. This episode of SE Radio, as well as all other episodes, is licensed under Creative Commons license. See the Software Engineering Radio website for details.